Good evening, everyone, and welcome. Today is September 14th, 2021. Thank you for joining us. I'm Phil Santonzi, and I am the program chair for ASQ Section 1510 here in South Florida. The presentation tonight, again, titled Moving Beyond DMAIC, Six Sigma Predictive Modeling and Text Analytics. With recent advances in computing, predictive modeling is no longer reserved just for data scientists and machine learning experts. You will hear tonight how, in the world of quality, predictive modeling is now being deployed by quality engineers. They screen for process inputs of highest impact to yield and quality and hundreds of manufacturing variables for likely causes of defects. This without needing to wait for non-conformities and failures to show up in control charts and SPC analyses. Then you'll see how with text analytics, we take it a step further to explore how companies are gleaning new insights from raw unstructured text data, such as customer surveys, maintenance logs, and competitor product reviews. So I now turn it over to Brian and Kemal. Thanks for being here.
All right, everyone. So as Phil mentioned, Kemal and I, we do work for the SAS Institute, which is the leader in marketing and analytics, artificial intelligence, big data. So we'll talk about a little bit of that later, because I know there are some who are unfamiliar with us, and we specifically work for the division within SAS known as JUMP. And that is the division that focuses on the interactive desktop statistical software that many of you are probably familiar with, some of our peers in the statistics world. So today what we're going to talk about is just what Phil mentioned. We are going to be talking about what's the next frontier. I think Phil actually mentioned some of the industry 4.0, manufacturing 4.0, quality 4.0, paradigm shifts that have been happening over the past few years. Well, let's talk about what that actually means for our profession, right? Of quality engineers, industrial engineers, manufacturing engineers that need practical application of quality 4.0. And then what we'll do to get there is we'll briefly talk about where our profession has come from, and then where our profession is right now in quality. Then we'll get into the next frontier, the practical applications of that next frontier, which are predictive modeling and text analytics. And then we'll walk through some of the concepts, showing you actually how to perform this. Again, we're going to use our own software, but these concepts are universally applicable. So feel free to, we're, like I said, we're going to use JUMP, we'll walk you through it, but many of these concepts are just going to be known throughout the industry. Someone was talking about big data, and I originally was not going to share this slide, but I do want to share it because it does highlight where SAS is as an organization in analytics and artificial intelligence. We are, according to Gartner, the leader in the Magic Quadrant for data science and machine learning. And you see some of the other accolades here, but we're going to show you how we take all of this insight and all of this knowledge and R&D investment and put it into our highly interactive point and click data analysis tool. So that is known as JUMP. You see it, as JMP, but it's just pronounced JUMP, and SAS is actually just pronounced SAS. And the users of JUMP are going to be your scientists, your engineers, and your researchers. So folks who are not data scientists by their day job, folks who do not have PhDs in machine learning or artificial intelligence, that is the group that gets the most use out of JUMP. So if we talk briefly about the history of what has led our profession to where it is now, we got to go back to the Industrial Revolution. And I'm not going to walk us through all of these because most of these are well known. But this is really if we do a retrospective analysis of the history of quality, this is what we would call quality 1.0, right? Where we've recognized that there needs to be some sort of standardized approach to, in this day and age, manufacturing. Then we transition into 2.0 and start to introduce some mathematics and physics to the world of quality and manufacturing. So you get the famous Walter Schuhart's control charts developed in the 20s. You've got the Ford assembly line that, one person works on one part, works on one part of the assembly line, and that's all they do every day, standardized work. And then you move forward into the 1930s, and then Toyota visits Ford, takes some ideas there and takes them back home to Japan. Duran and Deming, and then go and try to find out, hey, what are these folks in Japan doing that are making them so competitive and so efficient with the limited resources that they had. Many of us know the TPS system that were implemented back then and are still very applicable to this day and age. And this is where we start to transition into 3.0, where companies begin to look at data analysis as a competitive advantage. And this was made most popular by Jack Welch at GE and Motorola when they rolled out their Six Sigma programs across more than just manufacturing. So this is when, kind of in the late 80s and into the 90s, when our profession really became spread throughout other parts of the company beyond just the manufacturing floor. Still has application there, still makes a lot of sense there, and probably has some of the biggest bang for the buck in manufacturing. But then maybe we're looking at, how do we do Six Sigma in R&D? How do we do Six Sigma in our process development, product development, and so on and so forth. And then really the last great feat of this 3.0 frontier was right here when Lean and Six Sigma combined. And some organizations combined it and called it one thing. Other organizations took concepts like Kanban, Kaizen, Blitz, all those kind of things, took them from the manufacturing floor, combined them with some of the Six Sigma initiatives that they had company-wide, and now they have things like Lean Six Sigma. And then that was expanded into other industries, particularly healthcare, and a lot of hospitals and clinics is where you see Six Sigma trying to be rolled out. They call it different things. In the banking world, it's called something else, but essentially they're applying the same techniques that the giants who have gone before us developed, nearly 100 years ago, and now it's just being applied to new fields and new industries. But what we're going to talk about today is, what is that next frontier right here? And that is known as Quality 4.0 or Industry 4.0, specifically to our profession. Generally, it's going to be broken down into these things right here. Automation of manufacturing systems, right? Manufacturing equipment becomes more intelligent. They introduced sensors, they introduced Internet of Things, where machines are talking to one another with very limited human interaction. Maybe control charts are being produced, published, and alert supervisors or engineers of problems that are happening, out of control conditions or out of spec conditions that are arising on the production floor, without someone going into a statistical program, charting the data, and then saying, aha, I have a control chart that says I've got something going on here. A lot of machine-to-machine communication, artificial intelligence, machine learning, these two are somewhat related, and then making use of big data. So big data, up until I'd say the past 5 years, big data has been reserved for those data scientists, those folks who can write those ginormous programs in a tool like R or MATLAB or Python. What we're going to show you today is, how do we make practical application of big data? So the two topics that we're going to touch on are predictive modeling and text analytics. So with predictive modeling, we actually have a lot of customers who are in high-end manufacturing, in insurance, and in banking that are using predictive modeling in the same ways that we were using control charts and fishbone diagrams to screen for those high impact variables that that affect our quality. That can be quality of a manufacturing process, quality of a product, customer satisfaction. The principles are the same. The application just varies based on the industry or the department that you're in. And the key with predictive modeling is now you are predicting when you're going to have failures and non-conformities without waiting for these failures to show up in actual manufacturing failures or customer dissatisfaction scores, net promoter scores that are in the tank. We're using predictive analytics to show you where we're going to have likely failures so that you can get ahead of that. The next thing that we'll cover today is how do we make use of text data? Text data we've generally avoided in our industry. Text data is something that it has been reserved for maybe marketing or customer service, but certainly not for quality and manufacturing engineers in the field. Well, with some of the advances in modern computing, we can actually make sense of text data. So we can glean new insights from customer surveys, right? Maintenance logs or engineering records that we've captured, and we're likely sitting on mountain loads or mountains of this data, but we just haven't done anything with it. And then a very interesting application that some of the high-end quality teams are doing for very, very competitive industries is competitor feature analysis and product reviews. So this information is usually publicly available. If you go on a competitor's website or you go through their product reviews, well, how do you make sense of what their customers are feeling about the competitor's product? And when you look at text analytics, it is important to understand text data in the context in which it is being delivered. So good may mean good to you, but it may not mean good, the same level of good to Kemal or to Phil. So you have to use analytics to begin to understand what these terms mean in the context in which they are delivered. That's the entire notion of text analytics. You get into some of the breakout topics known as feature analysis or sentiment analysis or term selections. These are all subtopics of the category known as text analytics. We'll show you how to do that as well. And the last thing I'll cover here before I actually turn it over to Kemal to show you how we step through this is this workflow that we have in JUMP. Now, most of what I imagine most of the people on the call are familiar with, whether you're using JUMP or you're using some other tool, are all contained within this one module right here, known as Quality Engineering and Six Sigma. So this is the module that's going to have your control charts. It's the module that will do your measurement system analysis studies. It's the module that'll do your capability and stability studies. If you have any FEMA or PFEMA charts that you're trying to draw, this is the module that you'll be using. But most of the time, this is what, right, you've been stuck with, or it's all maybe you've known up until now. What we're going to talk about, though, in JUMP is down here. So this is available right alongside all the normal features and modules that you would expect in any kind of statistical analysis tool. But maybe we'll show you some things that you're not aware of or not using right now. You certainly have the analytics capability to do so if you can do this. We'll just show you some things to maybe stretch your perspective of what you can do with data. But before I turn over to Kemal, I did notice that there are a few people that had mentioned in our intro, maybe it'd be great if there was a way that you could have guided data analysis. So if you're just given raw data, whether it's numerical text data, how do you make sense of the data? How do you have a logical approach to exploring that data? Well, JUMP is going to show you how to do that. JUMP is designed so it'll walk you through what the next most logical analysis technique to make is based on the type of data that you're looking at. So if you're looking at categorical data, your analysis technique is going to be very different than if you're looking at continuous data. And that idea is pervasive throughout all of the modules of JUMP. And we'll just touch on that a little bit tonight. And then I think it was it maybe Steve that talked about maybe there was a gap in data exploration or exploratory analysis skills within students or within professionals out in the working world. We'll show you some of that tonight. We certainly won't be able to cover all of it, but maybe it would be good if after this call, you guys have some internal discussions, you want to invite Kemal and myself back to touch on any of these other topics. That would be perfectly okay, because we'll show you some techniques that are available in the tool. And then design of experiments. This is the last one I'll talk about. I know Diego had mentioned when you're designing experiments, right, the idea is to reduce the amount of trial and error and experimentation associated with your process or your development or your R&D efforts. JUMP has all of the classical designs that you can think of, the classic full factorial, half fractional factorial designs, but we also use a little bit of hands-on machine learning to have custom designs. If there are areas of the design space that you do not want to explore, but you need to understand and extrapolate within, we've got ways to design custom experiments so that the tool itself fits your problem instead of the problem needing to fit the tool that you're using. So a great example of that is if we look at the classic designed experiments where you're exploring temperature versus pressure. Classical design of experiments is going to tell you, you have to explore all of these spaces of the design field, right? And then we'll be able to, once you explore all 9 points, you're able to explore what happens here, what happens here, what happens here, and make some educated guesses about what should happen out here, and out here. In JUMP, you can actually design it so you do not have to explore all that. You can actually just say, I only want to run experiments kind of around here and completely avoid this space right here, because you know that will cause some detrimental or unwanted effect with your real life process. JUMP will use machine learning to design where are your best design points and then extrapolate within those, within that undesirable area to say, this is probably what will happen if you combine high pressure and high temperature. So that's one that Diego or any others who are looking to explore design of experiments and some of the modern techniques associated with that, you might want to take a look at some of the things that JUMP can offer. Without further ado though, let's turn it over to Kemal to show you exactly what Phil talked about at the beginning of the presentation: predictive modeling and machine learning and text analytics for quality engineering. Kemal?
Thank you, Brian. I wanted to start with kind of quick summary of how the DMAIC process goes. We have an understanding of what the problem is, we define the problem, and we measure and collect data, and then hence we go analyze, improve, and control to make sure that the changes that we implemented kind of working for us. What we'll talk about today is basically what kind of tools available, what we can do to improve this analyze space on the DMAIC. Because when we're talking about DMAIC process, we're kind of limiting ourselves to, in general, linear regression and in some sense decision trees. And there's a reason for that. The reason for that is, of course, those are first easier to implement, and second of all, that works. But as we start going into fine-tuning our products and we have more computing power, and so in going from 20% quality to 60% quality with linear regression, it's doable. But when you go from 80% to 90%, now we start looking for very fine details on our process. So we need more different modeling tools than just linear regression. So that's what we'll talk about today in the next half hour. We'll talk about the predictive modeling tools. We're going to learn from existing processes and data. And we'll use that to predict future behavior. So this will be our structured data. We'll have just the numbers and the categorical values in this data set. We'll talk about that. And I also want to spend some time talking about the pitfalls of regression. And Steve, you'll probably agree with this. As we're doing some regression on our data, there will be some underlying assumptions. In a lot of cases, when our data is coming from sensors or we have some observational data we want to make use of, the underlying assumptions about regression, they don't generally hold. So we'll talk about the pitfalls of regression, and then we'll move on to using what we learned to apply to text analysis, where we'll do the same thing for unstructured data. So instead of talking a lot about what it is that what is it we're trying to show, so let's go open up a data set here. The data set I have here is coming from a manufacturing problem. We have 3 different outputs. They're looking at the yield and a variable called melt flow index and color index. What they're making is they're making a polymer that will be used on making plastic chairs. And throughout this production, they're keeping track of process variables that be how fast they're mixing up the slurry, how much modifier they're using, how much filler they're using, the source material, pH and temperature and viscosity of the water they're using, and of course, which shift, who is working this particular shift. If I were to go to, in a classical approach, to build a model for this particular data set, what I would do is I'll go pull up my regression platform, and then I'll put my response here. The most important part to me, of course, when we're in manufacturing is yield. I'll put my yield, and I'll put out all the other factors that might go into this process. I'll just put them in here. So here's my main factors. And when we're building these type of analyses, we also want to look at the interaction of these factors. What happens if I increase the current, if I mix the slurry real fast and the temperature is high? Is it the same effect as if I just increase the temperature, or if I increase the filler, or if I increase the modifier? So those are the kind of things that we generally look at when we're doing one factor at a time analysis. And in my case, I have only about 10 factors, but what if you have 20, 30 factors? How will you go ahead and look at them one at a time? And how do you convince yourself that interactions do not matter, or they do matter? So I'll do what I'll do just to answer that question. I'll pull those in as well. And I'll say, okay, look at the response surface modeling. This is the most expansive one. I can look at the interactions, and I can look at the square terms to make sure I look at every single term possible very quickly. And these tools are built in. And I want to talk to you about the concept more than how to use the tool. But if you have any questions on how to use the tool, we can talk about that as well. And what I will do is I'll get a simple report, and I can get every other information I want later on. And by default, this is our default solution when we're doing DMAIC analysis, our least squares regression, and I'll say run. And the very first thing I need to do is I need to see which factors are important in my process. And it looks like how fast I mix up the slurry and the viscosity of the water is important. The square terms for the current is important. And I get a blue line here that tells me the statistical significance of each of these factors. So I can feel free to say, okay, let's just take all these factors, get rid of them, because at this point, I'm only interested in what factors matter. And here are my main effects, my interactions and square terms that come into play. And when I'm building a model, this is kind of like what we talked about earlier, democratizing, building models, making it accessible to everyone else. And what I will show today, the only statistical measure that we'll have to deal with is the R-square value. And R-square tells me how much of the variation in this data set I collected can be explained with the mathematical equation behind this model. And when I talk about mathematical equation, it looks like, let me just turn this on here. Here's my mathematical equation. It found the inflection points for me. It found the intercept, and it found the coefficients for each of these terms. And on top of that, we also identified the terms for the categorical factor. This is fine. I can take this for an Excel spreadsheet and try to calculate the expected predicted results. But I don't think any of you, any of us, or if I don't want to put an equation with 8 significant figures and then try to make sure that the results are predictable. But instead, what I can do is I can turn on my profiler, which will take this equation and visualize it for me. And I can interact with it. I don't need to know much about writing brand new software to see what happens if I increase my current on the way I'm mixing my slurry. I don't need to know much about mathematical equations, write them in put them in Excel or anything like that. I can just interact with it. And this gives a way to the engineer, to the R&D scientist, or the manager to look at the data and say, okay, you know what? If I change my supplier from query A to query B, I'm going to have about 2% drop in my yield. If I were to use another supplier, it's going to go down to 91% if I keep everything else the same. So they have information, they have access to those new modeling tools. They can do their own informed decisions without coming back to you and asking you, can you do this analysis for me again? Can you do this analysis for me? It's a lot of time savings and also get the results they were looking for. And this is also I can use to say, okay, look at this data and optimize it for me. What are the conditions for me to get the best possible yield given this model that I have? And I'll say maximize and remember, and it gives me settings if I use, 80, the current at level 80, the 3.6% modifier and 18% filler. This will be the most possible yield I can get, and that will be about 122%. So this is where we run into trouble going with the traditional analysis of least squares regression. If I were to go and present this to my manager or supervisor or whoever that might be, say, okay, look, I did all the analysis and I came up with the best model possible and I can get you 122% yield, and I'll be laughed at out of the company because there's no way I'm going to get 122% yield. Here's where we can combine all the tribal knowledge sitting on the company, our subject matter expertise to say that this model, although mathematically looks correct, in reality, this is going to get me in trouble because I'm never going to have 120% yield. In situations like that, we need different modeling tools. And in different modeling tools being the very first one people go to is, okay, you know what, instead of building a regression model, I'll do a decision tree. And I can do that. I'll go do a decision tree. I'll go to, under analysis, I have a tool for decision tree, and I'll do the same thing. I'll put my yield, and I'll put all my factors, and then say, okay. My overall yield on average was about 95% with the standard deviations of 9. And then I'll say split and identify the most important factor was my current. And if it's less than 52, my average was about 60% with standard deviations of 20. And if my current is greater than 52, my average goes up to 97% with standard deviation of 2.45. I can decide, okay, now this looks better, so I'll go try to model this portion of the data. I can do that. But however, again, now I start mining the data, I'm cherry picking the data, and there's always trouble with that. Because I don't know the reasons why this particular level of current is giving me very different results. And I only have 5 data points for the low end of the spectrum. Are they reliable? Are they not? I'm not sure. And those are like the main pitfalls that I wanted to talk about earlier on regression, is that my variance needs to be constant when I'm building a model. I'm not going to go into details of statistics here. You can read through that. But the main thing is that when I'm building these type of models, I need to figure out what to do with the outliers. I need to figure out what to do with the missing data. I need to make sure I have enough data points to be able to build these models. I want to make sure that I'm not extrapolating. And finally, the most importantly, I want to make sure I'm not overfitting. I'm not giving myself a false confidence that the model that I build will be applicable, will be generalizable. So depending on the type of data that I have and depending on different distributions that I have, I can decide, go to on the analyze tool, there are different types of models. I can try to build a neural network model. I can try to build a decision tree model. I can try gradient boosted trees. Those are all available, and it's going to depend on the type of data that you have. And Brian mentioned earlier is that what we want is you being the subject matter expert, but not necessarily write a thesis on how these algorithms work. We want you to use your process knowledge and understanding of the topic to drive the modeling effort. So because of that, under analyze, the predictive modeling, I'll go back and talk through different modeling options if any of you are interested in later on. What I'll do is I'll go to my model screening tool, and it will be the same thing. I'll put my response, here's my response, and here are my factors. And these are all the available machine learning tools that I can use. My decision trees, the jumps implementation of random forest algorithm, gradient boosted trees, neural networks. So I'll make it simple. I'm not going to do the support vector machines. This is not going to be applicable because it's a continuous vector. And then I'll just put the XGBoost as well. I can use different k-fold validation if I'm interested. And I'll talk about the validation in a second. And in the modeling option, I can add my interactions, I can add quadratics, and I mentioned earlier about the missing factors. When I'm building a model using missing factors, generally I have a few options. One is I can ignore the whole observation, or I can try to impute the missing values with the average of the whole variable or the median of the whole variable. But there are there are pitfalls, and there are of course the right way of doing it, the wrong way of doing it. It's going to depend on your expertise. And we come across this in a lot of cases when you're trying to make a decision of if, let's say if somebody's applying for a loan and then they left the personal income level missing. If I take that missing value and replace it with the average of the whole participant column, they'll be different if I use a different batch. If I use a median of that column, it might be different with a different batch. So it's not going to be reliable. But if I check the box for informative missing, now I can use the missingness as a different factor, and then use a model with the missingness being an important factor as well. So I'll check my two-way interactions, I'll add my quadratics, and all I have to do next is say, okay, actually no. What I need to do is I need to add a validation option. So the way validation works is that when I built this model earlier, and I think I have the model already saved. When I built this model earlier, let me just bring this back up here. What I did is I use all the data available to me. If I go towards the very top, it tells me I use all 110 observations. And if I were to use this model as a predictive model, I'm making an assumption in the future, all the data will be similar to what I'm looking at right now. But the chances are that's not going to happen. The underlying statistics, underlying distribution of data might be similar, but what I'm collecting in the future might not exactly be the same structure, same portion of the distribution. So what I need to do is I need to build a model that is generalizable to the future variations in the data set. So I need to build a model and I need to validate it so that I can make sure the model I'm building is not going to be overfit. I'm not going to memorize every single thing in the data set and then fail to recognize the underlying structure. I might rely too much on the noise and missing the signal. So think of those in terms of I need to build a model and I need to validate it. I need to make sure that the model I'm building is generalizable. And because of that, I select the validation option so that the software the algorithm will build models and it will validate them with unseen portion of the data. And then it will give me the results, how predictive that model is in unseen methods, unseen portion of the data. And I'll say, okay, it'll take about 20 seconds. and then says, looking at the data, the best model will be XGBoost, and then it will be neural network, self-learning neural network model followed with the random forest regression. If I were to use just training, my least squares regression was number 3. It was giving me about 98% R-square. But scroll down on the bottom, the same least squares regression is only giving me 16% R-square, an unseen portion of the data. This is the predictive value of the models that we're building. But we're basically saying that I want a model that performs in similar levels, both in my training set and the validation set. And depending on which one are you more comfortable with, you can decide I'm going to use an XGBoost and neural network solution, and you can decide to go whichever one that you want to implement. So with all this, I'll select my neural network here, and I'll also select my least squares regression, and I'll go to my profiler, which is my interactive tool, and I'll play with that and then see what my responses will look like. And you notice the huge discrepancy, not discrepancy, huge prediction levels. My least squares predicts to become about 93.87%, but some it will be in the range of 80 to 108%. I mean, you can see the confidence intervals are pretty big on my linear regression. However, neural network gives me a smooth solution I can interact with and get the results that I'm interested in. So it gives me a way to interact with the results, and I can use my tribal knowledge and understanding of the process and say, or maybe something happening in the process line and say, you know what, and the water supplier, they changed their formulation. My viscosity is going to now be about 8%. So my viscosity of 8, how is that going to affect my responses? I can interact with that and get the results that I'm interested in. So it gives me a lot of flexibility on building a model, then I can implement. And of course, once I have a model, I can get the equation either to use it in JUMP, or get myself a Python code, or get myself a SQL code, whichever the way I want to use the model. It gives me flexibility, either just even type it in Excel if I wanted to. So those are all available as well. And this is all nice and well. And if I have a handful of variables, even about 10 variables I have, this is going to be pretty fast to build these models and interact with them. But what if you have hundreds of variables? Before you go into this model screening them, what I would do is I would go to my analyze under screening. This is where you also find your tools for exploring outliers, dealing with the missing values and things like that. I'll go say predictor screening. It will ask me again, what's my response? My response was the yield, and here are all my factors, and then say okay. And what this will do is, let me just turn this back on. It's going to build 100 decision trees. And each of these decision trees, it's going to use random number of rows and random columns. And from those random columns and random number of rows and about 100 different decision trees, it's going to select which factors showed up the most. The current showed up the most, and then the modifier showed up the second, and viscosity showed up the third. And if I go back to my original model, and you see my current showed up as important, my viscosity showed up important, and my modifier percent showed up important as well. This is a very powerful tool. If you have more than a handful of variables, you can focus on what matters, and then you can either build your model accordingly, or you can say, okay, I need to go and design an experiment to verify these factors are actually important or not. If only have certain amount of time or resources variable, money, because each experiment takes time, would you be, by just looking at this predictive screening, would you be spending all time and money on your modifying your temperature and filler and the pH levels, or controlling your current that you're using better than previously? So this kind of gives me which one to focus on all at once right away. And there's a lot more here, and I'm trying to fit this into time that we have left. But if any of you have any questions, whether the concept or the tool, how the tool works, or the concept behind these modeling options, how each of these different modeling options work, please feel free to reach out to Brian or myself, and I'll be more than happy to talk to you about these models. This is kind of like I'm passionate about. So I can talk to you about those and answer any questions that you might have. That being said, let me stop here to see if there are any questions from anyone before we move on to analyzing text data.
I have some questions where we can see some graphics about outliers, and if we have some influencing points or leveraging points. Also, I mean, if we can check the assumption of the regression.
So if I go to this red triangle here on the very top on my FX screening, I can get my scaled estimates. So it tells me which factors and how they're comparing to the results. And I can go turn on my sorted estimates. I can get my, let's do something else. Let's go do this in a different way. Let's go to my relaunch my analysis. And I'll say, okay, show my effect leverage and run the model accordingly. Continue, here's my leverage plots. I'm assuming this is what you're referring to. And I have my residuals. But if you have anything particular that you want to see, we can also talk about that as well. Is this what you mean? Is it what you're asking about the leverage plots?
Yes, and also we talk about multicollinearity, so we can see. I believe we can check that using the variation infection factor.
Right. So if I have my once I get to my profiler here, let me go turn my profiler on. And under a triangle here, I can get I can assess my variable importance. I can get my variable inflation points. I can't recall where they are right now, but that's available that we can get those as well.
Right. Thank you.
Mm-hmm. And I mean, if you want to, we can also do like a special, I mean, answer the questions here. We can have a side session as well. But those, I mean, all the questions you asked, they are within the platform, they're available. So if there are no other questions, I want to move on to the text data. Let me close this out. And what I have here is a very simple data set. And we have about 140 different users. They're asked to eat some potato chips and then basically provide their comment on this particular potato chip. And they collected data, and we have some general information about these customers, if they're male or female, and what flavor of potato chip that they tried. And we also asked them if they're going to buy again, and what rating they basically give to this particular potato chip. And previously, when we were building models, we need a response. Let's say if I go to the model here, I have a response factor that I need to specify, and I need some factors that go into the process. And I don't have that for text. Only thing I have is a simple test here. It's unstructured text that I need to deal with. And under analyze, if I go to analyze, turn my text explorer, I'll just put my text column as my text column. And I want to basically set my minimum characters to 4. So I can eliminate A's and N's and this or any other numbers maybe, but you can specify, you can customize this if you want to for yourself. And I'll say, okay. And very first thing I get is list of all the terms and all the phrases that show up in the particular product review. And very first thing people look at when they do text analysis, they want to build a word cloud so they can see which words show up the most. And since I'm asking people to look at the flavor, and of course flavor will show up on my, then that's kind of like, it's kind of like expected. But what makes this tool extremely powerful is that if you've done any text analysis in the past, if you're either writing your Python code or R code, whatever that might be, you need to decide, you need 2-word phrases, or you need 3-word phrases, 4-word phrases. Jump does this automatically to the side, depending how many times they show up. You can pick up two-word phrases or four-word phrases, and it will automatically find those for us. So what I'll do is I'll select some of these top phrases, and I'll put them as part of the term and phrase list, and go back to my word cloud. So again, the flavor is showing up. Right-click. I can control this and say this is going to be my stop word. Do not show it. I can modify this word color, word cloud by, let's do this, color them by their star rating. So look at my star rating. Now I can take this, I want this to be centered. So you can see which ones show up most importantly. And it looks like wickedly good is one of the words that show up the most on my word cloud. But right now though, I don't have any way to associate this to my, what's interesting to me. What's interesting to me if this particular person will buy again, and what rating they're going to, what rating they did provide for this particular potato chip. So what I can do is I can go to my red triangle on the very top and put a filter on, say, you know what, I'm going to take this word cloud and I'm going to start filtering by flavor. If it was balsamic, what did people say the most? They said it was salty. Well, you know what I'm going to do? I'm going to show this as a single category. So I can select, if I were to do barbecue, I expect them to use the word barbecue. So that my assumption holds. But if I do original, how do they specify, how do they qualify? They use the word wickedly good and they loved it. And for all the people looking at the original flavor and they use the word wickedly good and they loved it. And what if they're going to buy again? If they were to buy again, let me make this something here, make this condition perfect. So with an original flavor, if they were to buy again, or if they didn't want to buy again, so if they didn't want to buy, what kind of words they used? They said it's nothing special. If they were to buy again, they said it's wickedly good and they loved it. So those are expected things. And I can do this one at a time. But instead of doing this one at a time, because you might have other factors that go into this analysis, I'll remove this. What I can do is I go to red triangle here and say, you know what, look at this, all the text that we have, and let's do a term selection. Which one of those terms respond the most if this particular customer will buy again? And I'm interested in yes levels. And I'm going to give, okay, just go through all the data, just give me a maximum of 10 words that I'm looking for in these particular reviews. So let me make this a little smaller here, and then say run. And I quickly get a list of all the words that show up. Salty is one of the main contributors. It was wickedly good, contributing positively. Salty was contributing negatively. And barbecue is contributing somewhat positively if the person is going to buy again. If instead I said, you know what, I'm interested in star rating and I want to know what contributes to star rating of 5, and I'll turn this, I'll say again, give me 10 words maximum, and I'll run that. In that case, now I have, again, wickedly good gives me most positive, and salty gives me the most negative terms. And I can interact with this and say, you know what, I'm going to take this wickedly good and remove from my analysis. And everything should get updated for me. In this case, the word that contributes most is salty. And I can also get a view of what the review actually said. And my other model for if they're going to buy again is also updated. And I can look at them, interact with it as well. And there's a lot built into this text analysis platform. I can not only build these models off the words, but I can get underlying topics. I can do latent class analysis. I can do sentiment analysis. I can identify the underlying topic that what people provided this unstructured text for. So there's a lot more here as well. And I know it's getting late. It's about 8 o'clock. But I'm going to stop here and to see if you have any questions I mean, if you don't want, I mean, if you want to put yourself off mute, and if you have any questions, we can answer those. But if you want to reach out and have a separate private conversation, we can do that as well. Brian, did I miss anything? Did we cover what we wanted to cover so far?
Yeah, I think that was it. Yeah, this is no way intended to be a tutorial, just a glance over of what is possible now with the power of modern computing, both for predictive modeling and for analyzing text data.
Well, thank you. Anybody have any questions? I thought that that text analysis is very interesting. I haven't seen it used that way before. Most people using survey information don't use the text. They really depend on the data responses, the quantitative responses to the question. They use the text to mostly, from what I've seen, again, to just reinforce, some of the things that they see in numbers.
Yeah. And so often what you'll see is like the Likert scale, right? They say rate us 1 to 5.
Yeah.
Right. But that is a very basic form. You lose the richness of how a customer is feeling when they gave you that score, which is where text analytics comes in beautifully, because you can, I mean, think about how much text data is out there. You can pull directly from social media, right? People are leaving you reviews on Twitter, Instagram. We'll pull that data and do something with it, right? Those people on Twitter and Instagram, they're not necessarily going to fill out a Likert scale, but they'll certainly give you their opinion on those platforms. Use that data to your advantage. So that is exactly what text analytics is about. Very, very heavily used in insurance, banking, and consumer products, but it is making its way down into manufacturing as well, because it shortens the feedback loop between customer satisfaction or dissatisfaction and the actual manufacturing process itself. Yep, so that's it, y'all. This is the last thing I was going to show you. For those who haven't done this before, who have never used Jump, you can actually go to jump.com. I left that in the chat room, and just try it. Go take this recording that Phil puts up online in a couple days. Go try to follow along in Jump. We've got some of the data sets up in the library, and try to follow along and see if it makes sense for your business or just for fun if you want. And then for those who are looking at possibly going into black belt, like if you're wanting to go get a green belt, black belt, we actually have a statistics course on Jump that is completely free, all online, that will take you through many of the modules that you're going to have to master in your green belt or black belt training to get certification, whether from, probably be from ASQ, but it also covers some other programs as well. That's on, if you go to jump.com, click on Learn Jump, and it's called the Statistical Thinking course. Absolutely free. It's perfect for those who are trying to hone their skills, improve their skills, and expand on their knowledge of data analytics. Phil, that's all Kemal and I had.
Okay, well, thank you very much, Brian. Thank you very much, Kemal, for coming and joining us tonight and providing all that useful information to us.